To understand the benefits of heat treating processes first requires an awareness of metal and alloy structures. When a molten metal solidifies, the atoms arrange themselves into definite patterns called crystal structures. The two most common crystal structures in metals are body-centered cubic and face-centered cubic. These crystal structures grow uniformly in all directions within each developing crystal. As the metal cools, these crystals are confined by the adjacent developing crystals, forming grains. The line of intersection between grains is called a grain boundary. Because the grains form independently, their crystal structures develop tilted in various directions. All atoms in these crystalline structures are held in place by electromagnetic attraction to neighboring atoms. If a force or load is applied to a metal, these electromagnetic bonds stretch, allowing the atoms to move slightly. When the load is removed, the bonds pull the atoms back into position. If the applied force exceeds the metal's yield strength, those electromagnetic bonds will break, causing permanent stretching or deformation. To make metals stronger and more resistant to deformation, it's necessary to strengthen their crystal structures. This is done by adding alloying elements, which are other metals or non-metallic elements like carbon. The addition of an alloy introduces foreign atoms within the crystal structure of the base metal, disrupting the structural uniformity. This disruption results in increased strength.
An icon recognized the world over, found everywhere from museums to your local county fair. Setting more recent techniques aside, let's take a look at the way they were made when the owner's life depended on it, also known as the right way. The basis for the katana actually begins with sand, specifically iron sand found on Japanese beaches. The sand is placed inside what is known as a tatara, a clay forge the size of a small car, the last of which is located in Yokata, Shimane Prefecture, and is still used to this day. Then, a fire is built over the sand using Japanese oak, and it is kept burning for 3 days. The carbon from the wood absorbs into the sand, which then forms an enormous solid block of metal called tamahagane, which is made available to only the top swordsmiths in all of Japan. At this point, the steel is unbalanced. Impurities run through the steel, along with pockets of concentrated carbon. The trick is evening it all out. The kitae, or forging process, was developed to correct these problems. The smith begins by testing the steel's hardness. Fragments that shatter easily are separated from those that bend. The harder pieces are then melted into a block, pounded flat, and folded into a block again. After 14 folds, more than 16,000 layers are produced. The folding process forms a pattern in the metal grain, or a jihada. Different patterns can be formed by varying the folding process. Remember the softer pieces? These are also forged together into a single bar to form the core of the sword. The blade is then wrapped around the core, and they are forged together, and the blade is shaped and bent into the celebrated curved shape that is so effective for cutting. Believed to be the most important part, the yaki-ire, or hardening, is the final step in crafting the blade. The smith prepares the blade for this final step by coating the back end of the blade with their own recipe yaki-batsuji, a mixture of water, clay, ash, and frequently their own secret ingredients. With no light in the room but the glow of the forge, and no way to tell the blade's temperature but by sight, the smith slowly heats the blade until crystal structures inside the blade begin to change, causing the metal to sparkle. At this moment, the smith removes the sword from the coals and plunges it into a tank of water. The heating causes all the elements in the metal to flow freely, and the rapid cooling freezes them into place. Any unevenness in the metal composition are now gone. Now, the addition of the yaki-batsuji causes the thicker core to cool much more slowly than the uncovered blade, so while the blade becomes the hardest known form of steel in the world, scientifically known as martensite, the core retains its softer properties and becomes what is called ferrite. The edge is now more suited for cutting and sharpening, while the core absorbs shock and prevents the sword from breaking. Most famously, the addition of the yakibatsuchi is what causes the edge pattern or hama, generally a saw-like shape. Traditional smiths each have their own pattern. The blade is now finished, and will be sent on to be polished, a process taking nearly a week and consisting of numerous polishing rags ranging from the size of a hand towel to just smaller than the nail of your pinky finger. Then it will be fitted for a handle and handguard. Truly a process to craft a home for the soul